Good evening, everyone. As me is my name. I want to present to you one of the project that I'm doing, one of the class that I'm taking right now. Uh, just want to give you the brief explanation of the project that I'm doing with respect to magnesium oxide using another software to do. The name of this software is called EDM. Basically, is discrete element method of simulation. So this simulation is done at a particle level. So this is very different from the atomistic level. So the particle interaction is what I'm trying to simulate with respect to magnesium oxide right now. So the introduction of this is to simulate using any of the discrete element method to simulate the magnesium oxide and see the mechanical strength or the mechanical property of the magnesium oxide with respect to the literature data that we have outside there. So basically what I'm trying to investigate with this software right now is to check the bond strength of magnesium oxide. So how does magnesium oxide how does the strength of the magnesium oxide compare to the literature outside that we have there? So like I said, this is not this is not atomistic level. This is on particular level. So what's going to be our driving force between the particle for this simulation is going to be integration of the force. This simulation, basically this software uses something that we call stiffness. If you could remember properly, the spring constant with respect to the force, basically the idea of the interaction between the particle that we are going to discuss here is going to be related to something like that. So the spring constant, the stiffness of the bonding that is existing between the particle is what we are going to use to simulate the interaction between the particle that we have in here. So there are two particles here. There is magnesium oxygen. So the interaction is going to define based on the stiffness between those two particles, and the interaction is going to be simulated based on the property of each of those atoms or each of those particles. Right now they are not atoms, we call it particles, but we still have to define their property like mass, density, and some other things like that we are going to use to simulate the interaction between them. So this is my model. I haven't created my model in EDM. Like I said, EDM is one of the discrete element software that we can use to simulate. So this is my model, the magnesium and oxygen with respect to the property with respect to their property. You can see that we have the two different color. One represents the magnesium and the other one tell us that this is an oxygen. The bigger ones represent the magnesium and the smaller one the oxygen. Because if you check the atomic radius of those two elements, you can see that the magnesium is bigger than the oxygen in terms of the atomic radius. So EDM, I went to the EDM. EDM does not need any code like lamps. EDM like property definition. You give the property of the particle that you want to simulate, and you define the interaction between them. So the stiffness between them, you give the value of the stiffness. You apply whatever simulation that you want to do, as we have as many simulations as possible, and you create your plane, or you create your environment. You define the physics between them. So when you do all this, so you run the simulation at the end of the day, and the simulation basically are technically divided into two based on the result that we get. So let me show you the results so that we can know what we are talking about. So like I said, in the first instance, I want to simulate the bond strength between the magnesium oxide, and model my simulation that I show you the first instance, putting the force on it and see what's going to be the reaction. Define the bonding interaction between each of those particles. So we see that when the force, this is the force that is coming down on this bonded particle of magnesium. So when the force is larger than what the bond can bear, it starts breaking. So that is what we want to see. We want to see at what instance, at what point the bond is going to break, or is going to tend to break or something like that. So as we increase the force, the bond between the magnesium oxide is trying to break, and this is the bar that shows us the value of the force that we are increasing here. So we divided this force into three sections, and summarily this is from 0 to 54 0.8 kilonewton. Those levels are the low category. As you can see here, those are the blue area, and the green area are the medium category, ranging from 54.8 to 218 kilonewton. High category is something that is much more tense, so those areas are going to the red area, as you can see here. So those areas are the much more critical area where the breaking, or where the breaking of the bond is being experienced most. Having done that, we calculated the bond stress with respect to the area contact, or the contact area that we define in EDM, and we see that this is a maximum bond stress that is being placed on the magnesium, and this is where the starting or the breaking is happening, and the compressive force that is very corresponding to that is 311 kilonewton from the simulation. So it can be concluded that the magnesium bond strength is well below this maximum bond stress, and at this stage the bond gradually breaks off while the bond strength decreases accordingly. So that is what happens. So we see from the simulation that the bond stress of the magnesium is well below this value, and that's why we are seeing it breaking off when the bond stress is getting to this place. So here are the places that I get my references with respect to this, and these references really helps a lot with respect to the tutorial on how to simulate the magnesium oxide. So thanks to my professor again, Dr. Jenk. He has been a wonderful professor, helping me helping me a lot. He has been very helpful to give the advice, giving the advice whenever that is necessary. So thank you very much. The credit goes to you a lot. So I appreciate you guys as well watching my video. The next time I will show you code to code, the step by step of how to define the material property, and show you everything that I did. This is just a brief explanation. As I said, this is just a brief explanation of what I did. So thank you very much once again. I really appreciate your stay with us. Thank you. Have a good night.